Okay, so UML, and this is a class diagram. We'll use them sparingly, but they can help you with your homeworks for the tic-tac-toe. So we create a block, right? And then usually the class diagram is like this, right? The name of the class at the top. And then plus sign indicates that it's a public, has a public specifier. So int get balance is public. Void deposit is public, and so is withdraw. And for now, we're using integers just to keep it simple, right? If it has a minus sign, then we know it's a private access specifier, right? So, and I showed you this in the introduction to abstraction, and that's how other classes see the bank account. And UML can help in giving us a picture of how classes talk to each other. For example, if, and this class will create it later today, but if we want to create an ATM class without worrying about how you're going to code it, first thing we do, right, is, well, how can they communicate with each other? How can they collaborate with each other? Like, so the ATM, we know we can deposit and we can withdraw and we can retrieve balance. So for now, we'll just focus on displaying the balance. So we're at the ATM, and then we're like, well, I want you to display my balance.
Stay over there.
Okay, so sorry. So then we are like, okay, so if I'm at the ATM, I need to display balance, and I will. Sorry, another student needs to come in. Okay. So void display balance, and how can it collaborate with bank account? Okay, so if I want to display balance, I know the bank account has the balance variable here, but I know that I can use the get balance function to accomplish that. So I know that my ATM class can use get balance in this function to display the balance, right? And then in order for me to use ATM, I need a bank account class variable. Okay, so, and that's with us without like worrying about how are we going to code this, right? So notice how class diagrams can help us at least get an idea of how our program's going to work. So we'll come back to this toward the end of class when we write the code for the ATM piece. Okay, so also let me come back to code, and where are we? -1, right? So let me open, this is ours. But I didn't get it mixed up again, so let me see, everything's checked in. Let me look at the code here. Okay, yeah, so this is ours. So if we are in the bank account class, and recall how classes are loaded into memory. First, there's a space allocated for the main function, and then assuming the main function has the bank account object here. Hold on. Can you all hear background noise?
I can't hear anything in the background.
Okay, thanks. Okay, cool. Okay, I can hear it, so, but I'm glad you all can't hear it. Okay, so where was I? Okay, so we load the program. Main gets a region of memory. Okay, and then this statement, assuming it's in main. Yeah, I'll filter the noise out on YouTube. The bank account A is loaded here, right? But the special variable that I want to introduce is known as this. Think in Python it was self, right? Self dot something that meant like this class. And I think this is also used in Java. I'm not 100% sure if it's in C#. I don't remember. Okay, so this pointer, when the class is in memory, we can say this something, like what's something, any of the public or private variables that belong to the class. And it's usually better if I show you with an example, right? So say we have a balance here, and then we're like, first of all, right, this is bad practice, right? I mean, we already have a class variable balance, but I want to show you how if we create a local variable here named balance, and our compiler will think we want to use this one. And you can see that, right? Like if we hover over it, it's like, oh, int balance. If I put my mouse over this one, notice it's balance that belongs to bank account class. So in situations like this, especially like if the parameter and some class variable are named the same, then we can say, okay, so I'm not going to use this one. That one's just for show, okay? But if I wanted to refer to the bank account, then I could say something like this, right? So now notice it's like, okay, the balance that belongs to the bank account class. And if I, for example, do something else with this one, just to show you, right, then this one is still this one right here. And you can tell because it's just saying like integer balance. And over here it's saying the balance that belongs to bank account, okay? Or the more common, we'll come back to this one when we venture into inheritance, but for now I just wanted to show you that that's one way to do it. But usually we do something like this, and notice now when I do this and then this arrow operator, it shows me the private and public methods or functions or variables that belong to the class. And then here I can just say balance, right? So now it knows that I want to use the bank account balance variable, okay? And usually this is very common in constructors, especially if like for example this was named balance, right? Then we would probably have to revert to that syntax that I showed you over here. Or sometimes for some reason you have two variables that are named the same in the function and the class, and this is how you can differentiate them, okay? But I do not really need to keep this changed. That was just because the book covers it, and if you read the book and then you're like, well, I wonder why I didn't cover this pointer, right? So that's the only reason I'm covering it. We'll cover it more as we move into other concepts in this class, okay? Okay, so no questions yet. Okay, so any questions?
So ideally you would just let the instance of the bank account implicitly access the private data, is that correct? But you were giving the example in case there was only in case there was like two balances. Am I understanding that right?
Yeah, like when you have name clashes, like sometimes the class constructor or for some reason somebody named them the same, so then that's how you can differentiate them. And then always remember that if you want to refer to the class in memory, this is how you do it. Like with this, and I just notice it's like, okay, so this class in memory, and then you can select any. But usually implicitly this will work as long as there's no name clashes. As we have it, it'll work fine.
Okay, thank you.
Yeah. Okay. Okay, so we move on. I think in the last lecture I showed you, right? Let me look at the code here. Yep. So I showed you that just because we create our own class doesn't mean that the value reference and concept reference concepts we learned don't apply to it. We can use them. And remember, I showed you the example. So that's what I was supposed to talk about here, but I mean, I've already talked about it, so I'm not gonna repeat it, okay? Just remember that once you create a user-defined type, then all the rules that apply to all the other core data types like integer and float, and even the structures from the standard library like the string and the vector, they apply to objects we create too, okay? Okay, so then what do we have next? So static variable. So recall from a previous lecture we talked about, let me go to the stack here. I talked about static variables where if you create this variable and use it in a function, then it'll persist or it'll keep its current value after that function exits, and then when you execute that function again, it'll have the previous value. So it retains its value throughout the lifetime of the program, and it is read-write, right? So we can change it. And the same thing can be done with a static variable that belongs to a class. Like the static variable will keep its value even if that class is destroyed and a new class is created, and say the value was 100, then the new class value for the static variable will be also 100. So it won't be reset to 0. So it keeps its value across objects that come and go, okay? Just like we did for the functions. And to show that example, let me come back over here. I'll go to the header, and then I'll say, so this was causing confusion to some students yesterday, so I'll make sure this is customer balance, okay? And then we say static bank balance. Actually, we need a data type, right? Otherwise, we're gonna get smacked in the hand. Okay, so there we go. So static int bank balance. This is the total of all bank customer balances, okay? So if this bank only has 2 customers and their total balance is $10,000, and then the bank balance is $10,000, right? One customer may have 5,000 and the other may also have 5,000, but the bank balance would be 10,000. So that's what this static variable is keeping track of, okay? So then we also need a way to retrieve that balance. So then we can say static int get bank balance, and we can go ahead and just simply define our function here, since it's only a one statement function. So we can just say return balance. Notice here how we initialize integer to 0. If we try to do that here, then it doesn't like us. It's like you can't do that. So we have to initialize static variables a different way. So we can go to the bank account.cpp, and we can do it right here before the free functions. And the syntax can be confusing, okay? So we say int bank account bank balance. We're gonna say 0, okay? So we're gonna initialize it to 0. In reality, like, we would have to go like get the lump sum total from somewhere and then initialize this one, right? But we're just gonna initialize it to 0 here. So this should be okay. So let me verify the syntax, right? So we come here to source. examples, module 6, bank, and then I'll simply right click and just do build, right? When you select build, then it just checks your syntax and builds the executable. It doesn't run it, but as long as you get exit code 0, you're okay. So meaning I didn't break anything. So how do we test this? Well, we can use a test case, right? So we can come here and we can say let's create a test case, test okay, and we can say, okay, I want to create a bank account object, give it a name, and then I can deposit something, and then I can say, okay, require account dot get bank balance equal 50, okay? And then I can go ahead and try to run this test case and let's see what happens. So we come back and we look for the test folder and examples. I was grading a lot of homeworks today, so I think that's why I'm going to the homework folder. Okay, so run in terminal. And it's building. And it's still building and linking. Okay, so we failed, okay, which is okay. So then we come back over here and we know that we created the variable, we initialized it to 0, but nowhere are we updating it, okay? So if we look at our header file, where does balance get updated? Gets updated in deposit and withdraw, okay? So if we are keeping a total of all balances, then we know that, oh, okay, so we need to maybe modify bank balance here. So then we can say bank balance plus equal amount. And then we can do the same thing in here, and we can say bank balance plus, minus equal amount. Afterward, we can go ahead and try our test case again. And well, we made the change, but we failed, right? But actually, it's kind of good that it failed, because that drives my point home that the static variable will keep its value over the lifespan of classes that are created and destroyed in our program. And in our test cases, all these test functions have instances of bank account. So what we are getting over here at the bottom is the total of all the values in here. Okay, does that make sense? Any questions, sir? So if we go ahead and draw a picture, right? So let me come here. I'll just make up some number, okay? So if we create an object and the static variable in there has a value of 40, and then this one's removed from memory, but then another one's created, and this one adds maybe like 50 to the static object, so now we have 90, and this one's then removed from the stack. And then if another one's created, and then this one subtracts 10 from it, then we have 80. But notice that the static variable is persisting or keeping its value regardless of what's happening to our objects in memory. So that's why when we run our test case, all these test cases, notice we're creating instances of the bank account, and we are making deposits and withdrawals and what have you. So then the total tabulated value is 330. Okay, so I guess how can we prove that? Well, we can go up here and start adding the balances, right? But I'm not going to do it. I'm just going to assume that it's doing its job. However, I don't think we got all the places where we update balance. Okay, so we have balance beginning 0, balance beginning at 100 in the constructor, 0, 100, 0, 0, 100, 0, 0, 0. So there's 3 cases where we have a bug, well, purposeful bug, right? And can somebody tell me where we can fix that so that we can account for bank accounts that don't start at 0? I kind of stated the answer while I was talking. So if you were paying attention, then you should be able to answer that question.
Should do it in the constructor.
Yes, in which one? Let me go to the header. In which constructor?
In the constructor that accepts the integer argument.
Yep. So right here, right? So we are updating balance, however we're not. Obviously, like this is a very narrow scoped example, right? Like if we wanted to use this like in the real world scenario, we would have to make sure that we wouldn't be double adding bank balances, right? But for this example, we're okay. So then here we can say bank balance plus equal, we can say balance or B, it doesn't matter, like because by the time this statement executes, this has already occurred. Okay, so we can go bank underscore balance plus equals B, or bank underscore balance plus equal balance, and it'll still be okay. So now if we go back and run our test case, we know it's still going to fail, but we wanted to account for all the balances in our test cases. Okay, so it's linking. Okay, so let's see what's happening here. Okay, so at least now we are covering our basis, right? If I go back to the CPP, like if we really wanted to make this correct, then we would have to initialize this to some value. And then once we did that, then we could assume that we didn't need to do this addition right here. Because if it's already an existing customer and this code had some other code that would get like the total bank balance, say like of 10,000 like I said before, then when we create an instance, we wouldn't need to do this because that balance has already been tabulated with whatever value we got here, right? Which would be 10,000, I guess, if I go with that same example. So if I create the bank account instance for one customer and start with 5,000, then I wouldn't have to add it again because then I'd be counting an additional 5,000, okay? So, but for this case, it's okay, just to show you that we have to be careful with how we structure our code, okay? So questions with what we've done so far? Okay, so far, no questions. So we go back to the test case, and if we were testing a static value, then we would probably have like an Excel or a calculator and just count the number of objects we're creating and keep a tabulation of the balance manually, and then we would put that value right here. And if we were like, well, it should be 630, right? Once we did all our addition, and then we would run our code, and that's how we could get the value for this guy, right? We would just have to go through each of these test cases and tabulate the balances to get this number, and then we run the code to see if the code's running as we expect it to run, right? So we can, I'm not going to do that, okay? So we can go here. But that's usually like how the test cases are written. Any questions on static variables for classes? Did I change it? Okay, I did, right? So it was just not updating. So let me up arrow space dash s enter. We always want to see this, right? So we should never trust ourselves. So then we're like, okay, I just want to make sure. So test static bank balance is the last one, and we're good, right? And notice again how our test cases are also keeping us in check, making sure that as we add code, it can check existing code, and we can also check new code, and if something breaks, we'll know right away. So that's the value of test cases. I'm pretty sure by now you should know, and by next week, with next week's homework, when you determine who wins in the tic-tac-toe game, then you'll be like, oh, so now I understand the value of test cases. Any questions here? Well, in this case, if we put this test case at the top and delete it here, or just put a copy up there, a copy. I just put top just to give it a different name. So obviously here we have 0 and 50, so we would have 50. And I'm just going to keep this one at the bottom. Okay, but this one will probably change now to what? 680? Oh, let's see. Okay, so run. Yeah, so if it's keeping its value across instances of classes that come and go, then it's just a matter of doing the math for this examples. So it's a building. Right, so 680, I didn't change it on purpose, right, but we should change it and it will be 680. So now we have a very clear picture that, oh yes, the static variable is keeping its value across instances and in classes that come and go for our program, and the test cases as a whole is one program, right? All those test cases is one instance of our program. Loads into memory, every single test case runs, and then our program exits. So that's why it keeps its value across all those instances. And linking, and notice we're green, up arrow space, dashes, enter, and now we have 680 and 680. Okay, so questions on static variables. Okay, so no questions, so we go back to our agenda, and now we have friends of classes. So first of all, let's go back and look at our header. So we know that private members of a class are protected by the class, right? I would have, as a student, I would have questioned this one. Like I would have been like, "Hey, wait a minute, what's going on there, right? Isn't this private, or I mean, what's going on? Like, is this considered part of the class or what, right?" Well, in this case, it is, right? However, can other functions access private data? From what we've learned so far with encapsulation rules or principles, we know that we don't want other objects to access our private data. However, C++ allows us to write some code that will allow a function or a class. We'll do the function today, we'll do the class in the next lecture. Allow a function or a class to access the private variables. Okay, and to do that, we have to create what is known as a friend function, right? So the class is like, okay, that function is a friend, so then it can access the private data. Okay, remember, we can still have control. Like, how? Well, we can use the const values, right? We can be like, okay, so I'm gonna let you access the data, but I don't really trust you, so I'm just gonna make you access, or have you access it read only. You won't be able to modify any of my values. And also, a friend function is not a class function. It's a free function. It just happens to be a friend of the class. And one difference between a free function and a friend function is the friend function, we have to define it within the class scope. Notice this one's over here, they're outside the class scope. Right, so they are free functions. But the friend function, we have to define it somewhere in here, like this, the header. And then we can write the implementation in the CPP file for that. And one simple example we can have here is, well, let's create a function display balance that is a friend function of bank account, and then see if it lets us access private data, right? So we have display balance defined down here already. So maybe we should name this new function friend underscore display balance, right? Just to differentiate between the two of them. Okay, so enough that. Let's go ahead and write some code. So we have to use the keyword friend, and then we can say void get, or not really, we say friend. I said what the class's name was going to be, right? Display balance. And then we can say, okay, const bank account object and this is the function signature, right? And it is recommended that we put the friend function away from public or private access specifiers. Although we should know that if we don't use private or public and then we write class variables, then they're considered private, right? So if we put this guy over here, then C++ makes that private. But it's always better to explicitly state what you are doing, right? So then we put it under private, okay? Because that makes it easier for everyone in the long run. No, it's not convention. I just happen to have this guy here. So I just named it friend display balance. Okay, so when you write the code in the CPP, and I think Timothy stopped by my office yesterday and he was asking me about const, and I'm like, well, const, you don't include it in the CPP. And then I'm like, oh, wait a minute, what am I saying? You do include it in the CPP. It's the friend keyword. So notice here I have the friend keyword, and then when I am writing the code in the CPP, then I don't include friend over here. So friend free function, meaning I don't have to put the friend keyword right here. Okay, I just do this, and then the compiler will know. Number one, what does this semicolon mean? It's a promise to the compiler. We're telling the compiler, this is the function signature or header. I'll write the code later on. So then the compiler looks for the code and finds the matching header, and it's like, oh, okay, this is the friend function. And here we'll say, okay, cout, and then we'll say friend display balance, just to show you that this function is executing. And then notice the syntax here, account get balance. It has to use this function right here to get a copy of balance. What we will do in this statement is simply say, well, I don't want to use the function. I should have access to private class members or variables, so I want to access that directly. How do I do that? Well, I have to provide the class name first, and then I can say dot, and notice it gives me access to the private variables. Notice right here, I have to use the function. Over here, I don't have to use the function. I can just directly access the value. However, I can't do any funny business, right? I can't try to modify it because I'm making it accessible with const reference, meaning they can access the original location in memory for my object, but they do not have the permission to modify it. And that's what we want, right? Since we are saying here display balance, so we don't want them to mess around with our variables. Okay, questions here? Okay, so no questions. Okay, so how do we use this? Well, since we're not modifying anything, we can't really create a test case for it. However, we can use it in main. So we can say, okay, well, I want to use it here. Friend, display balance. It takes a bank account as its parameter. So I can say account. And then I can go and run that program. So notice right here, friend display balance. So we were able to execute this function right here. C++, when it's running, it's like, oh, okay, you want to use this friend function. And then it's okay. It lets us access the private data member directly. And like for object-oriented developers that are purist, meaning they want to always like keep the encapsulation of a class to the highest integrity, they don't like friend functions. And then there's developers who like friend functions, right? Because, well, it gives them access to private data members. If you work at a C++ shop, when you get the programming guidelines, you'll know if you can do this or not, right? So would say that if it was maybe, I'm not 100% sure, but maybe legacy programmers like the friend function, and maybe like modern purist object-oriented developers are like, no, we can't use friend functions, right? But it's a feature of the language, and it's covered in the Gaddis book, so that's why I cover it here. Questions? Okay. Notice how we are developing our class, right? We started with get balance, and we progressed to make our class, give it more functionality, right, as the lectures go on. And we'll continue to do that, right? So if you have questions, please do not hesitate to I think we do. I don't remember. I think we do. We do, but that'll be like three or four assignments down the road. So for now, don't worry about it. Yeah. Okay, so we talked about UML. We talked briefly about this pointer. We talked about static variables. The friend function is private because it is not marked with an access specifier. No, it's not. No, I mean, if it was private, we wouldn't be able to access it in main, right? It's just a free function. It's a free function. So, and notice here, we have proof that it's a free function because we don't have to link it to like the bank account. We don't have to say like, hey, you are from the bank account. No, we don't have to do anything like that. So what I was trying to say when I was here is that if we don't put an access specifier and we just write something like this, then this one right here is considered private. But that doesn't apply to the friend function. When the compiler sees this, it's like, oh, okay, this is a friend function, so access specifiers do not apply to it. That's what I was trying to say. Okay. Pretty cool stuff, right? Okay, so what next? Object composition and header guards, right? So header guards are important. It's if we, well, probably you don't remember, right? But I'll refresh your memory. When I was talking about how the compiler gets our source code and then starts creating a very large file, and then it compiles that file into machine language, it'll do whatever we say. So if we're like, hey, include bank account in one file, and then we have another file include bank account. So now it has two copies of bank account in that large file. And then we do one more, then there's 3 copies of bank account in that large file. And then but the compiler, once it starts trying to compile it, it'll be like, hey, wait a minute. Bank account's been defined once already, and you're trying to define it again. Like, you can't do that. You can't have 2 user-defined types that are named the same. That's where header guards come into play. So if we come back here, we can say, well, this is a class, and I don't want to have issues in the future, especially since we're going to use the bank account in the ATM object. So then we add what are known as header guards, and that's very simple. We just simply say if not defined, and then usually it's the name of the class, something like this, right? So underscore header. Then go ahead and define this macro or this global variable, and then at the end, right after, we'll go ahead and, it doesn't matter, those are free functions. What did I do yesterday? We'll do it over here. And if. Okay, so now if we include bank account in 3 different files, the first time the compiler encounters this header file, if not defined bank account, no, it's not defined yet. Okay, define it and then include all of this into that large file that you're getting ready for compilation. And if. And then it runs into another include in a different file, then it'll run the first statement, if not defined. Oh, bank account's already defined, bank account underscore H. So then it doesn't include that this code again, and then we won't get that error that's saying that the bank account object's already been defined more than once. So that's why header guards are very important. So we have to make sure that from now on, anytime you create a class, even if you don't think you're going to be including it all over the place, save yourself some time and make sure you add the header guards, okay? So I think for the tic-tac-toe application, I don't ask you to write them until we add the second class, right? So meaning, oh, so I'm going to add a second class. Yes, I'm going to add the ATM object today. So when you add the second class, I think is a tic-tac-toe manager, and that class is going to be keeping score of all the game instances in the tic-tac-toe games, and it'll have a vector of tic-tac-toe games, right? So that's when you'll need this header guards, but I won't jump ahead too far, right? So okay, so any questions on header guards, right? If you don't understand what I just said, then at least understand that if you create a class, you need these 2 statements here. If not defined, bank account underscore H, define it, and then end if. And then you'll save yourself a lot of time in the future, okay? Okay, so we go back here, and then we go to the UML chart. And I was talking about this diagram at the beginning of the class lecture. And I was saying, like, class diagrams help us because we can, if the requirement is that we need to use the bank account in the ATM object, and we can look at the outside view of bank account, and we know that we can get a balance, we can deposit or withdraw. And we're like, okay, so for now I'll start slow, and I'll say, well, let me create the ATM class that has a public function void display underscore balance, and knowing the bank account class has a get balance function, then I know that in my ATM class I need to have a bank account instance or variable that I can use in the display balance. Okay, so that's what we will do right now. Any questions with what we're trying to do? If the header files are in different folders, it depends. It depends on like if you're using CMake. Remember, I ran into that issue a few lectures ago, where two files had the same name, and I had to put the absolute path to the header file to choose the one I wanted to use. That way the compiler wouldn't be getting confused. So that's what you would have to do. You would just have to put the absolute path from your source code folder. That way the compiler knows which one you want to use. Yep. Okay. So what else do we need before we go and write code? So we have display balance, bank account. Where's my pen? Let me. Oops, Control Z. Forgot to click the pointer. The marker, here we go. So then I know that if I have this bank account object, I prefer to get it initialized, right? For now, we're going to take the easy way out. And then we'll modify this ATM class in the future, right? But for now, we'll be like, okay, so what I know so far is that I can get an instance of bank account through the constructor. And it'll work for this example, but if you really think about it, that's a flawed concept, because usually the ATM runs 24/7. So if we keep the constructor, which we will right now, we would always have to be restarting the ATM to get a new customer, okay? We will fix that in the future, but for now, we'll be like, okay, so I know I need an ATM constructor, and I will have a bank account. Where is that reference? Okay, something like that, right? A reference. Okay, and we have one constructor. Okay. So then we're like, okay, so I think now I am ready to write some code. I can go to this piece right here. I can go over here, and then I can come here, and I'm like, okay. So I know that from now on, anytime I want to create a class, header guards, if not defined, ATM header, and usually that's the recommended method to do, right? Like, I guess if we're going to be deploying our code, then we would probably have like our company name here, right? Like maybe company name or something. That way it wouldn't clash in the future with other classes that would have the same name, right? Here, the same variable name. But for now, we're okay. Okay, and then end if. This are header guards, okay? And we write the class code within the header guards, define and end if statements. So here we can say class ATM. Again, please don't forget that semicolon, okay? It'll give you a big headache, right? Because you're gonna be like, my code's right, my functions look good, access specifier looks good. Why is it telling me that, you know, something's wrong? So please don't forget this. Okay, so we will have a private bank account. We need to include bank account here. We don't want to create a copy this time. We want to reference, so we'll just say account. And then we have public specifier. And we'll have the ATM constructor. Bank account. And then we'll say, okay, when you execute, initialize account with a. Okay, so we have a reference, and we say, okay, when you execute, initialize this account with the incoming bank account value, okay? And then if we go back to our UML, what else do we need? We're like, oh, okay, so let's create this function, display balance. So we're like, okay, so void display balance. Since we are just displaying balance, this is a very good candidate for the const, so that we are not able to modify the value. And we can go to the ATM CPP file, make sure we include ATM. Okay, so again, just to make sure that we understand this, this will be considered a free function. If we want it to be part of the class, we have to specify the class name with that double colon. Okay, once we do that, notice it's like, oh, okay, I know what you're saying now, I know what you're trying to tell me. Okay, so ATM, I need include IOStream. Go back to ATM, using cout, and then I can say balance. Balance what? Account, right? Which account? This account right here. Okay. Account dot get balance. Maybe a new line here. And now we have an ATM class that leverages an existing class, and we're kind of like making a very dumbed down version of an ATM machine, okay? Here, questions here? Okay, so no questions. One question I would have asked is like how is this working? Like if I was, a student, I'd be like, wait a minute, okay, a reference, okay, so then I guess this is pointing to some other object in some other code, maybe like in main. So we come over here, this is an existing bank account, so then I'd be like, oh, okay, so maybe when I pass it in, then I'll be referencing this directly, right? So, but if you understand that, then you probably, if you understood that, then maybe that's why you're not asking, right? Maybe you just don't know what to ask. But that's what I would have been like getting clarification on. Okay, so how do we use this? So let's go to so how do we use this guy? Well, we have to create an instance of ATM, and for the moment we are forcing users of the ATM object to give us a bank account instance, okay? When I add the other code that's gonna make this better, you'll be like, okay, so now I know why you started easy, and then like we'll make it better, okay? So, but for now, let's just go simple. Okay, so I say that we need to create an ATM object, and I need to pass in an account, and of course I need to help the compiler by including the ATM.header file. Once I do that, then I'm good, and afterward I can say, well, ATM dot display balance. Okay, so what's gonna happen? Well, let's run it. So we have a balance of 100, right? Which is this statement, but maybe let's just be more explicit and let's put ATM balance just to make sure that it is running that class function. And then we scroll down a little bit up. Oh, it's right here, right? So ATM balance, notice how we are collaborating with two classes now. We have the ATM object that requires a bank account object to be functional. And this is known as a dependency, right? So the ATM depends on the bank account class. So questions here? Okay, so no questions so far. Can we test the ATM class? Well, this is returning void, and we are not modifying anything. And we've already tested the bank account class functionality, so we should be okay. Like, number one, we can't test it because this is void. But number two, this is cons, so if the bank account test cases are passing, then we can feel very confident that our ATM object is going to work. And that's usually how the unit testing works, right? Like, I mean, bank account is already nicely tested. ATM's just a proxy between the customer or the customer and the bank account, right? Just like the teller was. So that's we're okay. Okay, so let me go back here to the agenda and private functions. Okay, let me see. When the bank account in private ATM, does that initialize this as a bank account? No, so let me come here. So the question is this creating an instance? And remember how references work. References are clones of something, meaning that they can't stand alone. So a reference to a class points to an already existing class, right? So say we had a bank account A, which I guess I removed the code, then and if we say, okay, B equals A now, and B was a reference, then B is not its own class, it's pointing to an already existing class. So if we come back and look at this code, we can conclude that this is not your typical variable. When the class runs, the class will not initialize this to something. But what it'll do is it'll be like, okay, you need to initialize me to something. And that something better come in the constructor. If it doesn't come in the constructor, I'm gonna create a syntax error and let you know. But we're like, yes, I know that. So I'm passing in a reference to an account in the constructor, and I'm initializing this account to an already existing object, bank account, right? So if we come back and assuming, let me get the eraser here, and let's keep that. Okay, so and let's remove that. Okay, so we have in main we have a bank account, account. So assuming it's placed somewhere here, right? So then this would be the region for account. And our bank account object, not bank, ATM object needs an account. So this exists already. So we're like, oh, how convenient. Let me pass you in. So now our reference that lives in the ATM object, account reference, is like, okay, so I'm pointing to an existing reference, which is this guy, right? So that's what's happening. It's only creating the bank account instance, and then account that lives in here is pointing to this instance right here. Okay, so it's not creating two variables, it's creating one variable here, our code is, and then our reference is just pointing to that existing variable. Does that make sense? Yeah. You see, that's what I was saying. Like if I was a student, that's what I'd be like, hey, wait a minute, what's happening here? Like I thought references were clones to something. And then, so I'm glad someone asked, right? Because it's only creating a reference to an existing variable, which is this guy right here. Okay, so we will continue developing a simple ATM object, right? It's not going to be anything sophisticated, but it'll kind of at least give us an idea of how you could develop an ATM model, right? Any other questions? Can it modify instance, right? Well, since we don't have const, we can modify it, but for now, since we only have this function and we have it const, it can't be modified. And if you think about it, we cannot make it const because the ATM object makes deposits and withdrawals. But we always say, like, unless you know that you want to modify the data, then use const. In this case, we know we do not want to modify the data because the function tells us display balance. We're like, oh, okay, I just want to display the balance. So just to protect my data, I'm going to make it const. Okay. But if when we create the deposit and withdraw functions, then we'll be able to modify them, and that's okay because we know that's the ATM's job, right, to update the balances. Okay, so let me stop here. You have a short assignment, it shouldn't be hard, and this one is, I apologize for the last time. I think I just gave everybody a 10, right, for the last one. So